Hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So in this video, I decided to challenge Gaurav with a data structure algorithmic problem, and let's see how he answers this. And we have kept the scenario as an interview one so that you get an idea about how does an interview span. And at the end, Gaurav has also given some important tips about that you can use in your interview. So a quick introduction about Gaurav. So Gaurav runs a YouTube channel which has around I think 4 lakh plus subscribers, where he teaches system design and is an absolute beast in that. His playlist has millions and millions of views, and along with that, he's the founder of Interview Ready, where he makes his courses and he does a wonderful stuff. I'll be leaving all the links in the description. And prior to this, he was working with Uber as a software engineer too. Before that, he was working with DirectEye. Prior to that, he was working with Morgan Stanley, and he does not belongs to any IITs or anything. He was from a very small college, and he has reached heights. And in the software industry, Gaurav is remarked as one of the best when it comes to teaching system design. So I'll be leaving all the links for Gaurav's channel in the description in case you're looking out for system design. You can definitely you should definitely subscribe him and watch his entire playlist. So without waiting, let's get started with this mock interview. So so Gaurav, ready, right?
Yeah, I'm ready.
Okay, so the question is specifically something like this. You'll be given an array of integers.
Okay.
So an array of integers is given to you. You can assume that all are positive integers.
Positive integers.
Yes.
Okay.
All are positive integers. Now, what I want is, I want you to tell me how many operations do you need. Okay, so the question is to find the operations. So now I'll tell you the target. So you can write the target as, you'll be given the array, so you need to change the array. Okay, you need to change the array into such that the maximum minus minimal in the array,
Okay.
max minus minimal in the array, is equal to n minus 1, where n is the length of the array. Where n is the length
N
of the
minus
array.
1. Okay.
Now,
Okay.
how can you change the array? Let's understand that. So you can pick any element, okay, and you can change that to any integer that you're willing to, like any positive integer that you're willing to.
Okay. Okay.
Okay.
I can do this.
Okay, and the one more condition is, once you've changed the array, all the elements in the array should be unique.
Should be unique. Okay.
Yes.
Okay. Okay. So on at every step of this change, so I am changing elements one by one, and at every step I have to make sure that all the elements of the array are unique. Okay.
Yes.
Is there something like the minimum number of changes?
Yes. The
needed?
question states you have to figure out the minimum number of operations such that these conditions are met. Like you can make changes, but I'm wanting the minimum that you require. So for an example, let's take an example. Assume the array to be 4253.
Okay.
Okay.
4253. All right.
Okay. 4253. So if you check out over here, what's the minimal? That's 2, right? Right.
Okay, so that is like n minus 1 will be yeah, the minimal
2,
is 2.
and the maximal is, I guess, 5, right?
5.
So if you do a 5 minus 2, that's equal to n minus 1, where n is the length of the array. So that's 3. So over here, there are no changes required. And all the elements are already unique.
Okay.
All the elements are unique. Okay.
Awesome.
So let's take one more example.
Right.
Let's assume you have 1, 2, 3, 5, 6.
1, 2, 3, 5, 6. Okay.
So over here, if you just make the last element to 4, that is 6 to 4.
Right. So this is, so if I convert this to 4, you're saying,
Yes.
then the maximum minus minimal will be 4, which makes this 4. Okay.
So there's one change and all the elements are unique.
Okay. So through a single change, we were able to do this. So we have to find the minimal number of changes and also ensure that the array is unique.
Yes.
Okay. Okay. So firstly, what's happening here is that if I have an array, these are the initial ideas which are coming to my mind. Maybe they're not very useful, but let me just try. If there is the maximum element is greater than n minus 1. Okay, no, that doesn't mean anything, because I mean I was thinking about if max minus min is greater than n minus 1, then yeah, then it requires a change.
Yes.
That's one thing.
Now,
And the initial
there's one more condition that's unique. You need to be careful.
uniqueness is also there. Yes. So okay, if it is greater than n minus 1, then I have to make sure that there is a change required. Otherwise, if it's not unique, there is another change required. Or if I can do them together, that will be perfect.
Yes.
Okay. Right. So let me think about how do I map elements. So firstly, let me take a very basic scenario and let's see if I can map everything to this. The permutation of an array is always valid. If I
Permutation of an array is always
valid. So if I have, like, let's say 5 as the size of the array, so I need 4 as the difference between max minus min. So I'm getting 1, 2, 3, 4, 5. Any permutation here is fine.
Right. Yeah.
Anything else is a problem. So what I'm getting here is that it can be a permutation of the array, and there can't be any duplicates. So the permutation seems like the only possible configuration, except, okay, I don't know if this is going to work out, but I'll just have a look here. Maybe we'll find a refutation here. Let's say we have a permutation P with the elements 1, 2, 3, 4, 5, and any variation of this is fine. Any permutation of this is fine. Also, any permutation with all elements minus x or plus x, so some value added to this, are fine.
Yeah.
Okay. So and in fact, this is the only possible configuration, is my claim, because if I exceed this, if I go more than 5, then I'm not going to be satisfying the condition of max minus min. And if I'm going to be less than this, then I'm going to hit some duplicate here. I'm just looking at the maximum element. Yeah, that is the only possible configuration that I'm getting here.
Right.
So I have to make this something like, okay, so one of the things is I can find the minimum element quickly, and then whatever the minimum element is, however far it is from 0, let's say, so if the minimum element, let's say, is minus, oh, you already mentioned that this is positive, so that's wonderful, because whatever is the minimum element, I'm just going to subtract that from all the elements of the array. I'm going to subtract that value from it.
Okay.
So I'm going to end up with a permutation starting at 0. So if I had, like, over here 2, 5, 3, so I'm going to take 2, which is the minimum. I'm just going to make it 0, 1, 3, and 2. Okay, this is just one thing that I can do. Okay, now all I need to do is I need to check if all the permutations are valid, and I need to check if all the numbers exist for this permutation.
Okay.
So okay, now just give me a minute. Sorry, let me just think about this. Yeah, take the base. Once I take the base, the thing that I'm thinking about is, if I have the base with me, or let's make this even simpler. If I have 1, 2, 3, 4 here, the only things that could go wrong, let's say this was 6, right? Taking this example where things were not fine, so this becomes 1, 2, 3, 4. Again, 1 is the initial element. If I subtract a of I minus 1 from all elements, then I get the same array again. And now I need to ask myself only one question: is there any element greater than 5?
Yeah, there can be.
Yeah, and if there is any element greater than 5, then map it to an element which is missing in this permutation.
Okay.
Okay, that is one approach. Or in this permutation, which elements are missing? So I'm going to get 4, and then I'm going to say, okay, the element which is out of the permutation, convert that to a 4. That will be a single operation.
Yeah.
Okay, so okay, let me write this down. I think writing it down will make the thing more clear, the procedure more clear. First thing that I'm doing is I'm mapping all elements to another field. So for example, if I get an array, all right, first I find minimum of the array. Okay, this is a value x. Then for all elements in the array, I do a of I minus equal to x minus 1. Now this converts it to element, the array having a minimum of 1.
Yeah.
All right. Now what I need to do is I need to say that for I equal to 1 to n, I need to see if the array contains it, or rather like from 0 to n minus 1, a of I need to have a frequency map.
Okay.
So this can be a Boolean array, or this can be, yeah, this can be a Boolean array where I am just marking a of I as true if it exists. So for I equal to 0 to n minus 1, if a of I is less than n. No, yeah, if a of I is less than equal to n, then mark the element as existing. So what's happening here is that if you exist in the permutation, then I'm just marking you as true. Okay, I already have you. If you don't exist, then there is a problem, and the problems will be like which people don't exist will remain false after this this for loop is completed.
Correct.
Okay, now I have the people who are false, and I have the people who are out of bounds also. So I need a way to find out who are the people out of bounds. This should be rather simple. If you don't satisfy this condition, then I just add you to a set. Add to the set a of I.
Okay.
Okay, this pseudocode, I'm sorry, it's not looking clear, but okay, so we have the people who are the bad actors in this set, and we have the positions which need to be filled. All I need to do now is just take each of these elements and then convert them, perform those operations to convert them into these values.
Yeah.
Okay, will this work?
Yeah, but the thing is, we're using a lot of things, right? Like I see you using a set, I see you're using something as an hash map or kind of a Boolean array. So can we do something where like this definitely works, but can we do something where we can just simplify this? The logic is clear.
Okay, I'll try to improve on this. How do I make this simpler? Okay, if let's say I try to remove the complex data structures from this. So the moment you are greater than n, okay. Okay. One of the things I can do is like instead of keeping an entire set and then mapping these values, I can just yeah, I'm keeping a Boolean array here, and I'm also keeping a set here. Instead, when I get an element which is out of bounds, I keep it in this set, and when I get an element which is missing, then should I populate it? Okay, just give me 1 minute. Sorry for that. I'll just think about how do I simplify this. So when we are talking about simplification, we are talking about how do we reduce the number of moving parts in this, or is it that the algorithm itself is a bit complex?
The algorithm is a bit complex because you're going to reduce everything. So basically, what you're doing as of now is you're changing the array, right? So that is something which you're doing as of now. So and after that, you're again using a boolean, and after that, you're using a set. So when you're changing the array, can you think of something where you can do since you're already modifying the array, you're not keeping it constant. Like you're definitely modifying the array. So can you just use that array data structure to figure out the answer without actually using any external data structures?
Okay. So fine. So instead of so firstly, like let's see if I can avoid changing the array itself. Right. So one of the things that can happen is I get the minimum and I get the maximum, and then right. So one of the things is I get the minimum value x. Now instead of changing the array, and thinking as a permutation, I can think about, hey, the maximum distance you can go from me, this value x, is x plus n minus 1. So if a of I is actually greater than this, then we have a problem and you need to be changed. That is one condition. Okay. So if you're greater than this value, what do I do with you? I have to actually change you into a value which is missing, which is going to be missing in the array. So okay, here's the place where I'm getting a little stuck. I'll just think about this a little more. I'm thinking about, hey, once I have this value which is an offending value, how do I find out a value which is missing? So okay. If I'm using a set, of course it's easy, but if I'm not, then what do I do?
How about thinking in a direction where you think of a window kind of a thing? Because like you stand at every element and you see how long can you go, kind of that.
A queue, you say?
No, yeah, kind of a, like instead of a queue, if you use a slider kind of a thing, right? Like if you think of like without actually changing the array elements and probably thinking because
Right. Okay. If I think in terms of a window, like for example, you are fine. Oh, sorry, there's a mistake here. Okay. Just give me a minute. I'm sorry. I'll just think about this for another minute. If I have this condition and if I have the element a of I now, um, I can find the problem element. Okay, let's say I skip over this element, and I move forward and I again take all the elements which are fine. So I get all the elements having problems first. Uh, yeah, and then I need to. So if I get all the elements having problems first, then I have to store it in a set. So if I want to avoid that, how can I avoid that? Well, okay, hmm. Okay, just give me one more minute. Sorry for that. I'm actually racking through my brains trying to figure out what's going on here. Uh, okay, let me try to reason the way out of this. Yeah, if there is a set of positions which are missing, then the only way that I can identify those set of positions is actually storing all those positions which are either which are missing, or doing a single pass and then finding out all the positions which are false. Um, okay, so let's say I don't have a set. Instead, I have something like just a single pointer, right? So okay, like yeah, order n. Okay, so firstly, I have a pointer to the first element in the array which is false. Okay, initially I go through this, I find out all the elements which are offending the Boolean array. So now I'm saying only offensive elements. So what I'm doing is I'm taking a Boolean array. If this condition occurs, then offend of I equal to true. So I go here and I mark it true. Rest all are false. Okay. At the end of this, what I'll have is I'll have positions where the problems are there. Okay. Actually, no, that's not true. Offend of I mean this element is pretty large, so this won't work. If this is not the case, if is less than equal to, then this is equal to actually valid is equal to true. So instead of finding the offending elements, I'm now marking the valid elements. So let's say the second element is true, the fourth element is true, and so on. Once this is done, I need to run another for loop again, if a of I is less than equal to x of n minus 1, so not less than equal to, now it is greater than, so the exact same condition. Okay, and then I'm going to be saying, okay, I have a pointer, so change, I'm calling this pointer change. If this is the case, then a of I is equal to index of change plus this minimum element. So change plus min. I have to see if this is coming correctly. I think it should be fine. Yeah, it will be fine. So change plus min. Yeah.
I did not get this. You did a valid of I equal to true. Basically, you're stating that okay, these are inside that conditions. Okay, so just a quick word, like how do you handle duplicates over there?
Duplicates.
Yeah, because if you do that valid I equal to true, let's assume there are a couple of elements which are same. That is something which will be missed, right?
Yeah, yeah. So if I do valid of I equal to true, means you exist, but okay.
To like
Yeah, you exist, but what if you exist multiple times?
yeah.
Right, right. Okay, so yeah, if the initial array has duplicates, then that's a serious issue. So well, if you already exist, can I mark you false? No. You don't exist. Okay, but if there's duplicates, okay. So duplicates I have not taken care of, and let me think about that one. This condition is useless if there is a duplicate, because the duplicate will be marked as true. So okay, right, now it's starting to look a little scary, like, because
Now, what if we think in terms of solving the problem without duplicates? Then your logic kind of works, right? So what if you
if it is without duplicates, yes, but if there are duplicates, then one of the other things that I have to take care of is probably putting the duplicate elements in another place. Like I have to actually make
yeah,
sure that there is another array which is
yeah.
marking the duplicates. Okay.
So like if you solve the problem without duplicates, then whatever answer you get, I think you can get some idea, right? Whatever answer you get, then after that you get
Okay. Okay. So let us say without duplicates, the thing is pretty easy.
yeah.
Instead of saying equal to true, what if I do a plus plus?
Okay.
So I'm actually keeping the frequency of these elements now instead of this. Yeah. Now what's happening is, let's say this is 1, this is 1, this is 1, or rather this is 2. Okay, and these are zeros. So they're missing elements and they're duplicate
Yeah.
elements also. So initially, change starts here. Change says this is 0, means there is no existing element, means we need something to actually do that, to satisfy this. So if you are an element which is offending which is not valid, then we need to change you to this thing. Okay, now how do I, yeah, so this and this. Okay, this will make sure that we get an element. Yeah, if you're out of the range, then I'm changing you, and then this will become 1, and change will come here. After that, I'll see that again. This is fine, so we'll just move forward. No, we basically have 2 pointers, one pointer here and one pointer here, and what's happening is change is being incremented
Okay.
up to the point that we get to a 0 or greater than 1.
Okay.
Not one value. So we come here again. I'm just roughly running through now. I know there's going to be a problem here, so I'm quickly running through. So let's say I make this also 1. I find an element which is out of scope, and then I come here and I say 2. Okay, here is a problem. At 2, what do I need to do? I need to make this 1. So if your frequency is 2, yeah, that might be another thing. So if you're either out of range, or a of I, the frequency is greater than 1. Okay, yeah, then I can convert you to this thing.
Convert it to what?
Convert you to what? Yeah, that's a good one. So what I need to do is uh, I need to actually pick you up and convert you to something over here. Convert you to the 0. Okay. Now, okay, intent is clear. Programmatically, how am I going to do it? Okay. If there's
Like the catch is like the difference is n minus one, so definitely all the elements are gonna lie in the range, right? That's the catch. If you think on it, all the elements are definitely going to lie on a range. As you said in the starting, that the permutations, right?
yeah, yeah, you're right. So if they are in a range, can I just I mean, I would ideally like to map you directly into a value. Uh, is that possible? Like, I don't know which values are missing. That's the only problem. Oh, how about I just take an element? Okay, how about I take an element
Okay.
and I say that okay, let me go through the array 1, 2, 3, 4, 5, 6, 7. Let's say this is a normal permutation 1, 2, 3, 4, 5, 6, and then suddenly I say that 7 doesn't exist. Okay. Okay. If oh, right. Okay. How about I make this super basic? Like let's say brute force. I know I'm going to use a data structure here, but I'm taking all the elements in this array, dumping them onto a set 1, 2, 3, 4, 5, 6, 7, and stuff like that. I mean, do you exist in the range 1 to 1 to n minus 1, 1 to n rather? Now what do I do? I need to actually. I think I'm going to fail this interview very badly. But okay.
No, but just a quick like intervention. Like your basic idea is revolving around one is to n minus one, right? Like, can you just shift that probably, like, because you know the answer if it is in the range one is to n minus one. It can also be between somewhere L and R, where the difference is n minus one, right? It can also be in that, right?
Yes, yes, but I'm worried ki what if I convert it and make it a duplicate and then
Why do you need a duplicate? Why do you need a duplicate? Like, let's assume you're removing duplicates, as I said you, right? Let's assume you remove duplicates, then you know how many elements are in a particular range, then you know how many have to be changed. If you can think in that direction, right?
but removing duplicates, okay. Initially, if I want to remove the duplicates, okay, let's say I make them
Because they're gonna be changed, right? Duplicates have to be changed. There's no other option.
correct, correct. So I want to minimize the number of operations. Okay, let us say initially I go for the duplicates and I find out that these need to be changed.
Okay.
Okay, so firstly, if this is the array, then I can just tell you the elements which have to be okay, these are the elements which need to exist. Okay, I need 3 elements and these elements need to be changed. This one needs to be changed and 2 more elements need to be changed from outside. So this is what I'm getting, right? So yeah, I'll just go pick up those elements, find where the changes. Let me see if this is simple enough. Maybe
Yeah,
I'm
you're complicating things.
okay. I'm sorry.
You're complicating a lot.
I'm just wondering if we have 2 pointers, isn't it going to be enough?
Yeah.
If this is one array and the other one is very clearly, let us say this is 2, 8, 7, 3, 4, right? What
Okay.
I need to do is I need to make this difference equal to between 2 and the maximum element to be 4. So 6 has to come somewhere. So okay, let's do this the frequency way. Okay, we have initially okay, yeah, no, yeah, the frequency way is not a great idea because the ranges might be huge.
Yeah.
Okay, so this array itself ideally should not exist. Now I come and I say, what is the minimum element? Let us say minimum I can find in order n, so there is no problem. That is equal to 2. Okay. You need to be, and maximum element also I found is equal to 8. Okay. Actually, the maximum is not needed. You need to be between, the size of the array is 5, so n minus 1, you need to be less than 6, less than equal to 6 for it to be a valid element. So for
Just
I,
like you're saying, it should be less than equal to 6, right? Why can't it be lesser than equal to 8? What if I change to? I can change to as well, right?
yeah, that's actually a good point. So one thing I can do is I can either change 2, or I can change 8, or I can change both.
Yeah.
Okay. Yeah, that makes sense. In fact, maybe that will help. Maybe that will bring down the overall number of changes. Okay, so this is not as basic as just saying that let's do it this way.
But as of now, what I'm feeling is you are revolving around the minimum element, right?
Right. Yeah. So
Probably you can sort and then think.
okay. Firstly, even if I, let's say, if I can sort things, then I can, let's say, directly truncate elements. Start truncating. So the basic idea would be that, hey, why don't I have between 2 and 8? Basically, I have 4 as the maximum difference. So which element should exist? This is no longer a minimum plus something. It's a range of elements which need to exist.
Yes.
Okay. And the range has to be between, has to be of size 4. Okay. Alright. Okay, so I have to choose an element which is going to be, I have to choose a value which is my minimum. Okay. Okay, one of the ideas which is coming on my head, although I'm not very sure, is that I should choose that range which has the maximum number of elements in it, but
And the duplicates will come in.
Yeah, duplicates might come in. Huh. Okay. This is. Let me try brute force. At least that might work. Okay. I try for all possible ranges of size 4, and then I basically go to 2 as the minimum, 3 as the minimum, or rather range starting 2 to 6, 3 to 7, and then 4 to 8, and then 4 to 8 I have to stop. So those are the possible ranges that I have. The number of possible ranges will be very high, will be at the size of a of I effectively, and each of those is going to take me order n time. So this is order a of I into n.
Are you sure it will take order n time?
So from in every range that I'm finding, I'm then trying to see if they're all within the range.
Okay.
So I'm also changing the elements in it.
Okay. So if you sort that, I think then it becomes easier, right, to find the range.
Yeah. So if I sort it, then it should be like, okay, 2, 3,
at least
7, 8. Okay. So and I say 2 to 6. Okay, fine. I have U3 and I need to change U2. 5 and 6. Yeah. So then I know I need to make 2 changes. Do I need to make the changes, or do I need to just repeat?
No, you just need to tell me the number of changes.
Okay. So yeah, if that was the case, then even earlier I just need to count the number of elements which are out of range and the number of duplicates.
Yeah.
So okay, that would be fine, but it would not be actually, because we are thinking about minimum all the time. This, if it is sorted, then it's great. All I need to do is I need to keep taking this range of left to right and keep moving it forward. So starting was 2, then I go for 3 to 7 again is another range. This should be done in log n time. Like the starting is directly coming over here, and the ending is going in login time, we'll be able to find that through binary search.
Okay, login. Okay. Can we optimize that?
Yeah, so overall time complexity is n log n.
Yeah.
Because we are sorting and we are also for every time we are moving forward.
Okay.
Can we optimize that? Yes, now the 2-pointer thing is coming to mind.
Sorting will. I'm okay with sorting, but probably you're using a binary search over there, right? Yeah. So without binary search, can we?
Yeah, okay, so without binary search, we'll have 2 pointers.
Yeah.
Initially, the start pointer is here and the end pointer is, you are within range over here. Then we move forward in the array, like this is, okay, we say that 2 elements need to be changed, so we report that value, that is one possible value. Then we say start pointer, please increment. Now the end pointer needs to be less than equal to 7. So that is end. At 8, we'll say that no, we can't go there. So again, the number of elements which need to change is the left hand side and the right hand side. So that is in total 2 elements.
Okay.
Then again, start increments. It goes all the way up to 8. So end also goes ahead, and then it's the end of the array. Over here, we report 2. 2 elements need to be changed, which is on the left hand side. If we go further, then it is going to be, going further is not going to make sense because the end of the array has already been captured. So in this case, what's happening is, because you're touching every element at most once and touching every element from here also at most once, you're going to have order n for the 2-pointer plus sorting. So order n log n.
Yes. Yeah. Sounds good. So how do you manage duplicates, by the way? Like, you're as of now taking the remaining elements and counting them, but how do you manage duplicates?
So in terms of duplicates, what can I do? One of the things that okay, if I have 7, so let's take the example of a duplicate. If I have 2, 8, 7, 3 and 4, and I sorted them, so 2, 2, 3, 4, 7 and 8. Now to manage duplicates, I need to identify that another 2 exists here. Okay, so firstly, when I come here, I'm going to say 2, and up to 6 I can go, so here. Okay, so but I'll wrongly report that 4 of them are fine. I could condense all of this into a single thing. Duplicates. I mean, I need to remove this 2. I need to actually get the entire array here. But if I sort directly, order n. Okay, one very basic way is to use a set and then to say that, okay, you are all duplicates.
That is something. Yeah, that is.
Yeah, that is there. The other thing that I can do. Just 1 second. Yeah. Okay. If I have 2, 2. Okay. What if you have 3, 3? That's another thing. So I can do a single parse over the array. I can say that if this is the array, original one, so I'm at 2, fine. Next element, are you equal to the same one as earlier? 2, okay, that's a problem. So I don't write over here, I just keep reading. Then I come to 3, I say, all right, 3, you're going to be added here because you're not the same as 2. Again I come to 3, oh, you can't be added. So my write still stays here while my read goes ahead to here, 4. Also I need a way to count those frequencies. Yeah, every time I do that, so I'll have a duplicate counter. Every time I actually don't increment the write, I just do duplicates plus plus and I keep moving forward. Yeah, this will be fine.
Yeah, sounds like, if I understood that, basically you're carrying one more pointer to count the duplicates, right?
Yeah, I'm just I'm moving forward in this array, and as I'm moving forward, if I see that the element has already been just written, then I don't increment this counter. The moment I see that there's a new element 7, okay, is not equal to 4, go ahead and write this down.
Okay. Okay, cool. And when you move, when you're moving the left pointer, then you'll decrease the count.
I'm not going to decrease the count. I'm just noting down all the duplicates. So when I was here, I just did a plus plus. So that was duplicates became 1. When I came here, it became 2. And then it didn't increment. So overall, I know that there are 2 duplicates.
Okay, but how will that help in your window?
Yeah, how once I've sorted the array, if I need to find out how many of these need to be changed, duplicates always need to be changed.
Yes, that's
So in that sense, I just need to do duplicates plus total number of elements which have to be changed for every sliding window.
absolutely
Right. So I'll find the minimum number of changes in the sliding window and then do a plus duplicates.
yes.
Yeah. So this will be order n first time for duplicates, order n for sliding window,
Yeah.
and for sorting it will be n log n.
So the sliding window will be on the entire array or just the unique elements?
Just the unique elements.
Yeah. Sounds good. We came an entire circle to solve this, right? It's simple enough, isn't it?
Yeah, it is. It is actually very simple. I just had to think about sorting, but
Yeah.
I started thinking about range counting, I think, or I don't know what happened, but okay.
Yeah. Sounds good to me. So yeah, so for everyone watching out, the solution is quite simple. What you need to do is you basically have to sort the elements. Once you have sorted the elements, and then you have to just take the unique elements. Once you have the unique elements, you figure out the range of n minus 1, because assuming if there are n minus 1 places, you can actually place every element in that n minus 1 places. So since there are, let's say, x elements, so apart from x elements, whatever remaining elements are there, it has to be changed. You don't have any options. And every slider, whichever is the minimum change, will be the answer. Well, a simple one, but actually, the question itself looks so daunting. The question in itself looks so daunting. That is why people start thinking in other directions.
Yeah, it is really interesting because overall I got that the pigeonhole principle needs to be applied here. That this is like a permutation, but then after that, I think a major mistake was to actually think that okay, fine, this is just an actual permutation.
Yeah, and one of the other mistakes was you were always thinking that minimum will always be there instead of thinking any other range can be the possible answer.
Correct. Yeah, that would have been totally wrong because it could be
Yeah.
that you can just take 8 and it's so much. It could be a much smaller number of changes there.
Like you change leftward, rightward, guys, and the middle element stays same. That would have been the answer. This is where you went into the wrong direction.
So is there? I mean, this is the fastest complexity, or is there like an even more?
No, this is the fastest. N log n, and you have to solve. Because everything else that you do will be revolving around set or something else using an external data structure in order to figure out the duplicates and everything else, right? So you're going to use something externally which will add up to a login factor, no matter what you do.
True. No, that's interesting. That's interesting. I thought you were going light on me in the end. Ki, okay, chalo, let's just go for sorting now.
No. I was basically telling you like, let's not complicate things. Let's keep it simple. That's it. As my yeah.
I think there's a really good problem. If you're going to take an interview of a candidate, this is really interesting. Can they think in these terms and can they think in terms of a range?
Yeah.
Sorting, binary search.
Yes.
Yeah, cool.
Yeah, so for everyone watching out, it's not about solving the problem. The interview actually judges you on the basis of how you're approaching a problem. It's not that at the end you have to solve the problem. Even if you're giving multiple approaches, the interview actually understands that you have the problem solving skill, that you're thinking in multiple directions. So don't always focus on that. You have to just give one approaches, even if you're giving, because usually we feel that 45 minutes is a very small time. Like that is what we feel when you're giving an interview, because 45 minutes is a huge, and you're feeling that when you're solving that, right?
Right. Yeah, no, I definitely feel like when I'm on the receiving end, I feel like 45 minutes is and when you're taking the interview, you go like, dude, I'm giving you so many hints. Why are you not getting it?
yeah. That's so. Yeah, Gaurav, you have taken a lot of interviews. Like, I think I'm assuming you have taken a lot of interviews, right? So, what do you feel when you take an interview of someone who is like in a DS algo round? What is the main thing that you feel like people lack?
So honestly, the first thing that I would appreciate any student doing is to actually communicate their thoughts. 90% of the people, although it does sound a bit like almost like a movie going on, like okay, I'm writing 4, 1, 3, 2. So that might be too much. But also, if you're just doing things right without communicating with the interviewer, they can't see what's going on in your head.
Right.
It's best to keep explaining what you're trying to do. And if you're running through an example or something like that, just tell them, I'm just seeing if this example works or not. That's number one. That's the most important thing according to me. And the other thing is, like if you're stuck somewhere, try to go brute force. Try to always fall back on something, and then the interviewer then, with these two things, communication and with brute force solutions, what happens is that an interviewer is like, they feel like, okay, take this hint.
Yes.
How about you try this? Like Striver, of course, is we are doing this on YouTube, so he's being nice to me. But in general, also interviewers usually go like, okay, fine, let's.
Yeah, seriously, like it's not like interview will be like completely pin drop silence and he's expecting you to do everything. If you're going in the right direction, the interviewer will give you like small hints, but you have to catch it. Like to Gaurav, I said, probably you can think without duplicates. So he could have catched that, and like I told you, probably in the 10th or 15th minute. So they will give you small hints, but it's up to you that you have to catch it and you have to capitalize on it. That is where you have to be very careful in the interviews, right?
Yep, totally agree. Yeah, and if you're writing any code, right, make sure that it is
Production level.
yeah.
Yeah, like I've seen I'll give you a perfect example. I see a lot of people writing if in bracket a of I minus 1 plus so greater than 0. Don't do that. Keep it in a variable,
Exactly,
whatever you're doing, and then write it in if, because I should understand what is that minus plus. How will I understand? So that's very important. The other thing that I've noticed people is, let's say they're using repetitive functions and they don't make functions. A lot of repetitive lines of code. So make sure you write a lot of, like, for example, a data structure like try, right? Like over there, you always use something like checking if it's a null or not. You use something like inserting. So a lot of people write inserting again, insert. So you have to probably make a function in the try structure or class, whatever you're making. So make sure whenever you're writing a code, you follow these patterns, because interviewers are not going to only judge whether you solved a problem or not. They're going to judge you on communication skills, how's your code quality, have you interacted well. So they judge you on all these aspects, right? So please make sure you cover all of these. Any other thing, Gaurav, you want to add?
No, yeah, exactly that point. What you said, just adding even more on top of that, there are times when people are not sure whether this person should be selected or not, a candidate should be selected or not. You know what happens? They can't hear you, right? So, and the comments are the interviewers. So they try to take an impartial thing, show me the code. And they don't see whether this code is compiling or anything. They just have a look at, did this person use variables? Is there too much duplication? That's it. That decides whether it's a yes or a no. That's crazy. But I mean, if 2 people are saying no and 3 people are saying yes, then you're not sure. You just have a look at the objective thing. Show me the code.
Yeah.
You might want to like be careful while you're writing code. Like Striver said, of course. Yeah.
Yeah, it happened with me in one of the interviews. I was not able to give him the solution that he wanted. Like we were like discussing as we were doing today. I was giving him something, he was saying, no, this is not working. I was giving, at the end, at the last 5 minutes, he was like, okay, you write the code whatever you're thinking. So you just wanted to see how my code quality was. And it happened in one of my Google interviews the last year that I gave. And well, I'm not sure what he gave as a feedback, but that is what he told me. Like I can relate in the sense that that is the reason he wanted to write the code even if the solution was wrong.
That's pretty useful because people, I mean, at the end of the day, you'll be dealing with code. So if you're writing code, if you're making functions, it's pretty useful. But this is good. Okay. I mean, I need to work on my algorithms. Yeah, then I understood. Yeah.
But you're 5 years, right? 5 years, I think 6 years now. 5 years graduated. 6 years.
It's been actually 7 years.
7 years. So yeah, he is still very good. Like he can at least think. I don't think if I don't do a lot of practice, I can think in that way. So thank you, Gaurav, for joining us.
Thank you, Striver. Thank you so much for inviting.
So I hope you have enjoyed the entire mock interview and you loved the tips that Gaurav gave at the end. So just in case you loved all the tips and you enjoyed and you did benefit slightly from this video, please make sure you like this video, and if you're new to the channel, do consider subscribing. I have left all the links to Gaurav's YouTube channel, interview ready, system design course, everything in the description. Please make sure you check it out. And yeah, with this, I'll be wrapping up this video. Bye bye, take care. Let's meet in the next one.